This is the Amp Hour Podcast, released June 18th, 2017. Episode 348. An interview with Art K.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
Hi, I'm Art K from Texas Instruments. And just a little background on myself. I've been practicing engineer since around 92. Graduated from Georgia Institute of Technology. And most of my career, I've been working in semiconductor applications, also semiconductor tests. So it's a very rewarding career, and I get to put together a lot of interesting collateral. I like to teach, even did a little teaching on the side, at different tech schools and so forth. And so as an applications engineer, I get to put together learning type collateral to help our customers with analog electronics.
Well, awesome. Welcome, Art.
Thanks for joining us, Art.
Thanks.
I notice I've got a comment, semiconductor.
Yes.
Is that commonly how it's pronounced inside TI? Or is it a local thing? Is it a local dialect thing?
I don't know.
Because to me it's semiconductor.
Right.
Not semiconductor.
Yeah, but Dave, you say a lot of things weird. Come on, man.
My own pronunciation, I guess.
Right, okay. That's cool.
Art's own
of course, we've got to
style,
start
man.
out with
It's
the important stuff, don't we?
Yes.
Right.
Well, that's great. And so I was mentioning to Dave as well. So you're down in Phoenix, right? Or Phoenix area? Tucson, sorry.
Yes.
Tucson,
And
Arizona.
that is the former Burr Brown facility as well.
That's right. Yes. I started out my career at Burr Brown, and
this TI rubbish. No, so are you still a Burr Brown man?
Yeah, there's the holdouts, right?
Are you still yeah, it's Burr Brown?
Yeah. In a way, I think there's a good bunch of us still in the
Right.
the facility, and we definitely are proud of our heritage.
That's great.
Excellent.
Yeah.
So it's still a separate facility. They didn't try and integrate it with TI facilities and move you guys, or is there are there physical reasons you're still remaining there, or?
No, there's a couple hundred engineers in Tucson, and so it's really the cool. Of course, we've hired many people since Burr Brown was acquired, but there's 3 buildings. It's a pretty substantial engineering facility. It's basically R&D. We're not doing production there, but when we were Burr Brown, we used to do production. We had our own wafer fab and so forth.
Yeah.
So you had a wafer fab on site, or?
Yeah, we did.
Right. So what happened to that?
Well, they shut it down. It was a 4-inch wafer fab, and really, by the time we were acquired, it was obsolete or becoming obsolete. So it was a timely kind of change that was important for Burr Brown to stay viable. They just didn't have the kind of wherewithal to create a huge semiconductor fab.
Given that the fab though was already sort of bought and paid for, would there have been any value in keeping that as a teaching training facility, or I don't know,
Dave,
some
you've never had to
experimental
pay for a fab,
facility or
have you,
something?
Dave?
No, well, yeah. How much? What cost would go into maintaining it? I guess I'm sure it's
Pretty huge.
Probably pretty
I think.
huge. Okay,
and I think a lot of the equipment was probably I'm just as conjecture really, because I wasn't in the fab, but I think the equipment was becoming obsolete and difficult to maintain and that kind of thing.
Right. Okay.
Yeah, getting kits and everything.
Gotcha.
Yeah. So Art, I mean, how you mentioned kind of the evolution of Burr Brown into TI and just the change over the years. I mean, how maybe we could start there from where you started in the educational world, and then kind of seeing how applications has changed over time. I mean, what is your view on the industry?
So I started in '92 in test engineering, which was pretty challenging and interesting because we would test the wafer and package level devices including trim. Do a laser trim on the resistors to increase the accuracy and so forth.
As in, you're talking about the silicon resistors?
Yes, right on the die. So on a microscopic level, you cut little chunks of the resistor away and, trim the offset or the drift or the gain error or what have you.
Now, I've got a technical question there, if I may.
Sure.
I've, under the microscope, I've looked at these things, fairly often, and you can see different types of cuts. Like there's L-shaped cuts, and there's square, and there's longitudinal, and there's chunk cutouts, and is there something to all those different geometry cuts?
Oh yeah, there's different geometry resistors. There's plunge resistors and top hat resistors, and basically, it amounts to whether you want to do a coarse change, a very wide change in resistance, or a very fine change. And frequently you'll have a coarse resistor and a fine resistor. And so you'll do a plunge, and that, creates a massive change in resistance. And then you'll do a more refined one where you keep cutting smaller and smaller pieces. And actually, the parameters are often measured while you're doing that cut. So,
Yep.
You're measuring offset, and you cut a little piece of the resistor. Sometimes there's some settling because the light from the laser disturbs
I was going to say,
things.
doesn't it heat it up? Does it heat it up? Because you're burning, or are you burning away the material?
You do.
I would have thought there'd be a thermal issue.
You do, but to my knowledge, there isn't much of a thermal issue. It's more of a settling issue from the light. And certain wavelengths of lasers are important, and the kind of focus of the laser to you have to cut through the top layers, and there's a lot of physics behind it. And once you have that equation, you can do a pretty good job of laser trimming. And even today, a lot of times people think of laser trimming as a sort of archaic or older technology, but it's still being used today because for bipolar devices, you can't really do digital circuitry on there. So a digital type trim isn't really feasible.
Oh, okay. So the other way to do it is like a modern digital trim,
Yes,
for example.
exactly.
Is that so? Are TI parts moving in that sort of direction where they can do it digitally instead of process?
Yeah,
wise?
both ways.
Right.
Generally, the bipolar devices will be laser trimmed, or and the CMOS devices will be digitally trimmed.
Because I'm guessing here, and correct me if I'm wrong, but because you're mostly dealing with analog parts here, you're not dealing with 10 millimeter by 10 millimeter dies or anything like that, right? They're really quite tiny dies, so you would have the extra room, wouldn't you, for the digital trimming and stuff like that? I mean, what percentage of the die would be taken up with that sort of extra trimming?
On the CMOS devices, I'm going to just guess some 30% or something like that.
Yep.
On the bipolar devices, those resistors can actually be fairly large and take up a good percentage of the die.
Yep. For power reasons, or is it just for value reasons? They physically have to be that big.
For value reasons, in the sense that to properly cut with the laser, you have to have enough space, physical space there's a certain width to the laser cut, and to get a fine change in resistance. Of course, economically, you always make the die as small as possible. And if you look at die from the when I started till die now, it's quite different.
Yeah. Right.
And what was the node when you were getting started and doing all that test engineering?
The node, did you say?
Yeah. Well, I guess it's different for analog, but just I guess generally what node it was, even though analog's usually trailing a little bit.
I'm not really sure, to tell you the truth. But I can say that the die were large enough to physically see.
Yeah, right.
And now they're not.
Yeah. And I guess like a 4-inch wafer as well. I mean, you could probably just tell by how many parts you could even fit on a 4-inch wafer. Whereas, there's still some operational 4-inch wafer fabs, but they're getting even more parts on there just from efficiencies and process and stuff like that, right?
Yeah, you'd have maybe a couple hundred die on a 4-inch wafer in the old analog days, and or analog processes, and now you get thousands to 50,000 die on
50,000.
And that, and that money, that
that's
savings comes
insane.
right down to us. So we don't, I don't mind.
Yeah.
Now, I've actually recently looked at a test wafer under a times 400 microscope and stuff, and I can actually see.
I feel like Dave's just like, I have a microscope. Everybody, I have a microscope.
Yeah, I've got
I love
a
my
microscope
microscope.
now. I like know all this. I'm instant expert. And do you guys put like test transistors on like the side of the die so that you can actually like test the parameters of like a transistor or some other thing on there, or do you just leave that at the entire die testing level?
There's usually, I haven't done it for a while, the testing, but when I did it, there was 5 test sites, one in the middle and then,
Right.
3 or whatever, 4 on the periphery. And they had different transistors and resistors. And, at the wafer fab, that's how they would make sure that the processing was being done correctly. And then after the wafer fab, they would take the wafers and run them through a more comprehensive test, measuring everything, and then decide whether or not to even use the wafers. If they failed that more comprehensive test, maybe the whole wafer lot could be scrapped. And of course, this is a long time ago, but I assume it's similar now. And after that, then my part would come in where I'd actually test and trim the wafers, and then they dice them up and package them, and then I'm back again and working with them in package form.
Oh, really? Okay. So you would see wafers twice, or well, I guess parts of wafers twice, huh?
Right.
Yeah.
Encapsulated or packaged, and then in wafer form.
That's interesting.
So how did you test these? Are there commercial universal testers that you can program to test analog parameters like this? I mean, it's easy to do some sort of digital testing, but analog is like, you require a lot of, testing functionality to test the functionality of wafer. Or did you have custom-made gear, or was it some sort of universal test system that cost $1 million or something?
Well, when I started, we had a lot of homemade testers, and some of them were IEEE rack and stack type things with a lot of Hewlett Packard equipment and and then
GPIB control. And
exactly, yeah,
Yep.
and then later, when there was also some hand built testers that we designed ourselves in house, and those would be less expensive than the rack and stack. And then now there's commercial test systems, which test extremely fast, and that's probably a different modern difference as well. The test times have gone down to seconds or sub-seconds, and you might test multiple devices, 8 devices at a time. So then they're being tested in parallel, and then you divide the test by the number of devices. You divide the time by the number of devices being tested. So you can get testing very quick on these modern testers, whereas it would be, 20 seconds, sometimes minutes for it per die in some of the older devices.
Right. And the testing's still done per die?
Yeah, every die is tested, and every packaged device is tested. And that's actually an important point that a lot of our customers don't realize. Is sometimes they think maybe some statistical means is done, but and not only is every device tested, but almost every parameter you see in the data sheet, not quite every parameter, but almost every parameter is actually tested.
And that is why you can pay $50 for a real high-end op-amp, right? Is because of the sheer amount of test involved.
Well, I mean,
test and full characterization.
I don't think any of our modern op amps are quite that expensive.
No, but you know what I mean.
Yeah, but yes, I mean you can definitely it definitely affects the price on the comprehensive nature of the testing, and
Right. Yeah. There's different speed grades and everything as well. Well, I guess speed grades different.
And if they're tested
there's
over
different,
temperature,
binning and everything like that.
Yeah, temperature testing's quite expensive.
Yeah. And so when you were doing this testing, Art, I mean, like what level of the design process was this? Are you talking about the actual manufacturing level where it's going through these ATs, or is this more you were working with the first silicon or pilot runs and stuff like that?
Yeah, that's a good question. There's two categories we call characterization and test. So characterization is what you were just mentioning. When the parts first arrive, a whole wide slew of different tests that usually make up the characterization curves in the data sheet are done. And that's a one-time kind of thing, and it's often statistical in nature. We look at distributions, we look at curves over temperature, and a lot of data, a huge amount of data is collected. So I was not a characterization engineer. I developed the production test. So my goal was to work on these test systems and get the test time down as small as possible and make it as accurate as possible. And it would usually test the kind of parameters that you see in the datasheet table, as opposed to the characterization engineers generally test the curves, all the various curves.
Right,
so if you look at a datasheet, usually there's a datasheet table first, and then there's curves. So the one-time kind of tests are done by the characterization engineer in the curve area, and then the production test, where each and every device is tested and before it's shipped, is done, by the type of engineer I was, test engineer.
Very cool. Yeah, and so and you would probably when you would see issues, right? Does that mean that you would go and feed it back to like a QA or a FA, like a failure analysis team, or how did that end up working in the was it in the fab or?
It would be in a final test, facility, which is a kind of clean room, but not the same level as a fab.
Okay.
And what I did was I did the engineering work, and part of that is to kind of do a capability study to make sure that the test equipment and program and so forth is all accurate, and we're going to have a good yield and so forth. And so a lot of effort goes into making sure that it's a robust solution. And then once everybody agrees and all the meetings have concluded, then it gets released to manufacturing. And so once it's released to manufacturing, product engineers would then take care of production issues. And they would, of course, call the test engineer if there's something they had difficulty with. But once it's released, normally the test engineer would work on a new project, a new device getting released.
Right, setting up the next line to make that nice and efficient, right?
Right.
Yeah. Cool. Okay, that's great. So how did you make this hop then from test engineering? Where did you go from there in your career?
Well, in test, I started testing instrumentation amplifiers. Then I moved to Delta Sigma converters, and then I moved to temp sensors, and finally I decided, well, I want to kind of do something different, completely different than test engineering. And I didn't even really know much about application engineering, but I heard a little bit, and it sounded kind of interesting. And I had, in grad school, I was a teaching assistant, and I had taught at a couple tech schools, and I liked teaching, and I thought this might be a good thing. And I'd written a couple articles prior to moving into applications engineering, and I heard that the apps engineers wrote articles. So I inquired a little bit, and the more I heard about it, the better it sounded. And it was really the best decision I ever made in my career, because applications engineering is very, very interesting. You get to do, I think customers will come to you often with their difficult problems, and you get to help solve those difficult problems. So you get kind of the fun part, I think.
Yeah, you're like the paratrooper of the engineering world, right?
Right, paratrooper.
Yeah. You come in and you fix you got to fix the emergency problem, and you move on to the next thing.
Yeah,
that's great. So what? I
love that.
Do you have any examples you're allowed to talk about that were like just off the wall kind of problems?
Let's see. Oh boy, that's hard.
Like I always think about like the month long ones, and then you have the eureka moment. You know what I mean? Like the like that's usually the ones that I think about. Like I had a memory issue in an FPGA a long time ago that I will never ever forget.
Let me see. I guess I've run across a lot of electrical overstress issues, and sometimes those can be interesting and challenging, where the part is blowing up in their system, and you got to kind of try and figure out if it's not necessarily a repeatable thing, it happens once every so often, and they just see a higher failure mechanism in this device, and something in their system is feeding through an overstress voltage, and you just gotta try and guess at what that is. And you don't really know for certain because it doesn't happen so often. You just make some recommendations as to what kind of corrective action you could do, and then if they don't call back and say it's still blowing up, then it's solved.
Yeah, right. So do you get a lot of customers like wanting to use parts outside of spec and asking if that's okay and if you can qualify it and?
Yeah, it definitely happens. They often want characterization done beyond what we've done. And
okay, so is that a service that you would offer them? Or?
No.
We try not to.
Yeah,
really.
That makes some bad habits right there.
Yeah,
you're right.
Yeah. In general, it's really a bad idea to violate the specs because they're usually set that way for a reason. I mean, there's something we discovered during characterization, some temperature, limit or whatever. And we always put guard band in, but just pushing the limits is not a good idea, I don't think.
Right.
Yep. Definitely did that way too much.
Yeah.
So, which division were you in when you got started in applications? There's a lot of divisions there. So, which ones did you end up sticking in?
So I was working in temp sensors from test point of view, and I moved into the analog group, which at the time, they changed from time to time, but at the time covered all op amps and instrumentation amplifiers, temp sensors, references, that's it. And there was a separate group for data converters.
Oh, okay, yeah, that's what.
And actually, I was in that group for quite a few years, after a few years, I became manager, and then just a year ago decided, well, I've done enough op amps for a while. I think I'll try data converters, and so I switched from the op amp team to the data converter team, to SAR data converters.
That's awesome. Yeah, and that's nice that you have that flexibility too. You can go between different groups, and obviously you're changing different roles and all the time as well. How long? So you've been at it since '92, so that's what 25 years, right?
Yeah,
man, that's another thing that's interesting to me is that like we don't really hear about that often anymore. Of just people staying at companies. So that's a good sign that you're doing interesting work and you like what you're doing.
Yeah.
Why do they separate out data converters?
Well, I mean, I guess it's from expertise product line perspective. They're broken down into product lines, and you'll have a design engineering team, a test engineering team, characterization team, marketing team, and applications team. And it would be it's easier for people to develop expertise, I think, in one area. Op amps, for example, and to have somebody work on the op amps one day, and then data converters another. Maybe from an apps perspective, it would be bad. In fact, it might be good because really applications is always systems level, kind of thing. And you can't work with op amps and not work with data converters. But from a product line perspective, it makes more sense to, separate it out.
Yeah, there's probably a lot of working together anyways between the different groups and creating different app notes and stuff like that. I mean, is that a big part of what your job was, is kind of doing this was like factory applications, is that right? Or
yes, it is.
Okay.
As opposed to field, which is more working directly with customers in a certain region.
Right. Yep. And those are the ones that I used to interact with a lot. And so, but every once in a while, it felt like the factory factory applications engineers would come out and also kind of go through the product lines, and that's always, was a really nice treat actually, just to sit down and talk with people that really knew the stuff deep.
Yeah, I definitely like traveling out into the field, and we'll go out and give seminars to customers. We'll directly work with the field apps engineers. Provide literature for them. App notes, articles, presentations. We have training seminars for the field themselves, where we can get a little deeper on amplifiers or data converters than they're normally getting. the thing about being a field engineer is you have to cover a wide range of different products, and it's very difficult for them to, become a super expert in, let's say, precision amplifiers. And so when the factory people go out to the field, they can kind of jumpstart them and get them, help them learn a lot of details about whatever the product line is in a very short amount of time.
Right. It always felt like a support organization. I mean, well, I guess just a technical one, right? I mean, but you kind of raise the, if there's a problem that the FAE can't solve, then they kind of send the email up the chain to whoever, and eventually, I'm sure it lands on your desk.
Yes, exactly.
Yeah.
And then where does the level stop? At someone with a long grey beard? Where if they right, we have to send out the grey beard.
Yeah, exactly.
It doesn't get that bad.
It does occasionally. I mean, people will be sent out for kind of direct customer assistance. You might end up at a site. I ended up once in China for a week working with the customers. So it doesn't happen very often, but it occasionally happens. You directly sit down with the field apps guy and you and the factory and the customer all work together.
I'm sure the bigger companies get the parachuting in a little bit more often, huh?
Yeah.
Right. Are there actual greybeards there of tweaking stuff with their tongue at the right angle? Sorry, I just have the Bob Pease picture in my mind of
Yeah,
tweaking something until are there real old timers like that?
Sure. Yeah, there's definitely a good number of them, and a lot of them from the Burr Brown era, and of course the different groups at TI National, they have their fair share as well. So sure.
So it's still an old timers game sometimes.
Well, I mean, it's interesting. I think the young guys ramp up much quicker than we did when I first started, and
Right.
I think part of that I'm happy is part of putting together this good training, because I was kind of left to figure it out. It's just like, hey, I figured
Yeah.
it out, you figured it out, right?
Right.
Trial by fire and blowing up op amps.
Yeah.
Exactly.
Right.
Trial by smoke. There we go.
But we try to make it easier. We with this Precision Labs training system and so forth. We I actually put interns and interns that come into TI or new college grads, put them through a training course, and at the end they take an exam. So and so it's kind of fun. I tell them, it's a pretty comprehensive exam. It takes 4 to 5 hours, and
Wow. Right.
So do they right back at the end and they're like, thank you, or are they like, see you later?
It sometimes it depends on the group. Frequently, they get really excited about it and they're very competitive, and they form study groups and they work on the weekend. They're like really into it. And then other groups are kind of sort of say, well, I've already done this in school. Why am I doing this again? I thought I was done with tests.
Right. Yep.
So, it depends on the group, but I say more often than not, we get very good response from the interns, and they're pretty excited, and they like to, I always let their score be confidential, but it never is, because they always start comparing scores to each other and so forth.
How do you see the engineers changing as from what they're coming in as? I mean, I'm always interested in, are the interns prepared for what you're putting them through, or is it, they just kind of pick it up as they go? What are you seeing?
Well, I think they pick it up as they go. I do a lot of college interviewing as well, and I think that there's so much that the university has increased the amount of different subjects. Whereas when I was in college, it was a lot more analog, and I guess there was there's still digital, right? But it was more focused, and now there's quite a bit more. I mean,
We've talked about that on the show a lot. Is this a good or a bad thing, or is it just the nature
thing, right?
of the?
That's a good point. Yeah.
It's just a thing. There's so much more stuff, right?
It's just the nature, but what it does have a negative consequence in that I don't think they're as prepared from an analog perspective in general. Sometimes you find
course,
superstars, right? But in general, I don't think they're as well prepared as they were 20 years ago. And that again, I'm not trying to be negative. It's just more stuff,
Is that more prepared from a practical point of view or from a theoretical point of view?
I would say both. Yeah.
Right.
Definitely both.
So just like less exposure to analog. So not that it's not capable, it's just that there's less time. That's kind of the
there's just more
fixed
stuff
time,
to
more
cover in a course.
Yeah, right.
Yeah.
That makes sense.
And some, so you'll occasionally get a guy who comes in and can, solder surface mount components and knows everything about everything. It's just amazes me. But more often than not, there's some
Hobbyist.
learning. Yeah.
Yeah.
Yes, probably.
TV blog viewers. Huh?
Yeah, probably almost certainly. So what are you looking for when you're interviewing college graduates? Do you not give a rat's ass about their scores and stuff like that? Are you looking for that hobby interest, side projects? What are you looking for?
Definitely hobby interests are really good. I mean, if they show me a project they've done, sometimes people bring a little pamphlet in or pictures of their project, and that's pretty good. And I'm always, you can tell the excitement in a person if they're really into their project, or, if somebody's kind of trying to fake it, you can tell that as well.
Right, yeah.
Yep.
You can tell in a split second we've just got a nose for these things.
Yeah, and then the other thing I do is I ask fundamentals of electronics, and some people get it very quickly and easily, and they're almost insulted by the simplicity of the questions.
I was going to say, can you give us an example of how simplistic the questions are? Because I ask real simplistic questions at interviews, and it's like,
Same.
I have a whole slew of them. I do an RC circuit with a DC voltage source, close the switch, and say, draw for me the waveform versus time, charging the capacitor. And I give values, and I ask them to mark the time on the axis. And you'd be surprised how many people really struggle with that. They start breaking out the calculus and so forth.
Yeah, right. Yeah.
Right, the delay tactics, right?
fail.
And let's see what else. I draw an op-amp circuit. I ask some basic math questions, like I'll draw a graph of a offset parabola and say, what's the function for this? You'd be surprised.
I'm out. Yep.
So, yeah.
Oh, well,
Are you sometimes looking, depending on the position, sometimes looking for those theoretical geniuses who don't know which end of a soldering iron to hold?
Yeah, sure. I mean, there are some people who are very, very theoretical, but they're good. I mean, they're really good. And not everybody needs to be able to, solder a board together.
I might take a little umbrage with that there. I don't know. I mean, like one board, maybe one board, right? But yeah, I know what you mean. Like, yeah, some roles do not require it, but still, everybody goes through basic training camp for the Army, right?
Yeah, exactly.
Right.
Well, I think a great way to get prepared for it would be this book. So why don't you tell us about this? So there's Analog Engineer's Pocket Reference Guide. I think we talked about it when it was released. It was a couple years ago,
probably.
Right?
Yep.
Yeah.
So tell us about it. What's the idea behind it?
So actually, Burr Brown had a little pocket reference, and my colleague Tim Green and I, we got together and said, this is a neat little thing, and it's been long since not published. What if we, resurrected this and created a new one? And so we just got to basically collecting equations and graphs and relationships, all these kind of things that people probably have bookmarked in their computer on a million different things, or 100 tabs in certain books. And, standard resistor table, for example, different things like that. And we put it all together in one book, and we're continuing to update it. In fact, later this year, I hope to do an update on it. And my goal is to kind of make just a handy book that has various useful relationships. I even use it myself all the time. I mean,
right.
So
right, it's just like you're storing part of. It's like, all right, my brain doesn't have to remember this part now. I just go flip up the book open, right? It's like how
Exactly.
we use Wikipedia,
And we recently put out a calculator version of it. It's called the Analog Engineers Calculator. And basically, it has a lot of the relationships that were in the pocket reference, but there's some additional things that can't be done in a hard copy type format. And for example, what if you have a voltage divider and you want a ratio of 0.372? What two standard resistors?
I've written one of those myself. I know, exactly. I've written my own one just to do that. It's like, it's something you can't get from a table.
Yeah, exactly.
Well, you do a lot of guessing and checking, but it'll save you a good 20 minutes,
But you've got to guess
right?
him. No, exactly.
Yeah.
No, it just runs through all the possible values in a split second, and bam, it gives you the answer of, you can combine these two resistors from the E24 range to give you this particular tolerance,
Yeah.
Yeah, that's really nice too. And then if you could switch it so that it's like, if I switch to E96, then it, my error goes down by this much. That kind of
thing. It gives you other ones.
Exactly.
That's
exactly.
Great.
Yeah, it tells you the error. Same thing with amplifier gain, and we have data converter tools in there. Figure out the noise for a data converter or noise of amplifiers.
Oh, really?
Different sensors like RTDs, for example. You put in the temperature, and then it tells you, depending on what type of RTD you select, it tells you the resistance. Thermocouples, a whole slew of different stuff. And again, that is going to expand with time too. So I'm always looking for good feedback from people.
Cool. Yeah, that's great. And we'll hopefully send a bunch your way. I think there's a lot of analog fans out there in the listening audience right now, or maybe even just people that are looking for a little bit of help on that kind of stuff too. It's like, having these kind of guides, it feels like, like Dave and I are very big fans of Art of Electronics, and, that's on my desk all the time. But at the same time, it's like, I know where stuff is roughly in the book, but there's just a lot of stuff there. So having it boiled down like this is nice as well. Is this something you actually carry around with you? Is it truly a pocket reference for you?
People have complained about that.
Oh, really?
Actually, they said pockets must have gotten much larger in the past 20 years.
Okay. Because the backpack guide, huh?
It's small, but it's not.
It is kind of A5 size or something. You could print it out on A5, but get a little, And it's got to be in the ring the ring type thing, so you can fold it. Yeah, the flip, so you can flip it all the way open.
Yeah, actually, you can go on ti.com and you can actually buy a physical book. So if people want that,
cool.
you don't have to get it in PDF version. And it's I don't know, it's something like $10. It's not super expensive or anything.
Right.
So
yeah, and if you have an FAE that's your buddies with, sometimes they give you one. So
yeah, when we go visit customers, it's a nice giveaway.
Yeah,
that's great.
Do you remember the point when PDFs took off and it's oh my God, my entire data book collection of 500 data books is now obsolete?
Yeah, there's a few people around that still can't give up the books, and they have these old yellow books.
Yep.
Nice.
Yep. I had 4 bookshelves completely full of just data books, at home. This is my own collection at home, because it was the only way that you could get data on stuff before the internet and before PDFs were online. But it was obsolete within 2-3 years, I think, when the companies just sort of switched over and digitized everything.
Yeah, definitely. It's nice having the digital version, because you could search through it and so forth.
Yeah, and I'm sure that, like you mentioned before too, you mentioned, it takes a little bit, it took a little bit longer to kind of find the knowledge that you were looking for when you were getting started, right? I'm sure that some of that is also, you had to dig through all those books versus being able to search through and go straight to what you wanted.
Yeah, the internet didn't exist.
Right.
No, it just changed everything.
Yep.
So do you remember the days of Maxim, for example, who were just churning out 500 new chips a year? How many chips were you guys doing at the time?
I don't know.
Because that was mid 90s, I think, where was that peak time of they were releasing a new data book that was 3 inches thick every 6 months of new chips. It was crazy.
Yeah, I don't know the answer to that one, but
maybe a good question is, do you know how many are out today? I mean, how much are coming out this year, from your group? Maybe that's a good reference point too.
I could tell you that there's thousands of op amps out there, already.
Just from TI?
Yes, just from TI. Thousands.
Oh, wow.
Thousands. And then hundreds of data converters. So It's quite a list, and sometimes it can be a challenge to figure out which one. You've got thousands to choose from, and,
Of course.
But
Like, are there that many different disparate customer requirements that warrant that many, or is it kind of like, oh, we need to bring out something new and we'll just tweak this, and
well, it's partly the marching technology moving on. The older parts don't really disappear. We keep supporting those.
right? Yeah,
And
of
thank
course,
goodness
you
for that,
can't,
by the
yeah.
way. Let's just say that up front.
Yeah. And some
sure.
of those even are the best sellers, some of the oldie but goodies. But with modern devices, you can get smaller and smaller packages, lower power, better performance. And then if you look at any amplifier, there's so many different parameters, and you can't optimize all the parameters. So if you
Right.
think of the different permutations, it does end up creating a need for a lot of parts. I mean,
Right.
it happens all the time that a customer will ask us for a particular amplifier or data converter, and we say, well, we've got this one, it's pretty close, but it doesn't meet quite on this spec, and they're not satisfied, and so we think about developing something new. And so in general, the new amplifiers and data converters they're not being developed just to create a new product, but they're filling a need.
Yeah.
Right.
It always felt like there was certain groups that as well, right? So like I'd be talking to an FAE and they'd be telling me about these new parts, and I'm like, oh, that sounds great, and then they'd be like, well, this is really for the automotive people though, and then you could kind of see that there was very certain specs on
Yeah.
the temp rating and the price usually for low quantity. I was like, oh god, okay. But yeah, I mean, it does feel like it's it's kind of just trying to fill all the holes in the marketplace, especially as new things come up, right? I'm sure that bio stuff and IoT stuff and all that crap is starting to change things too.
Yeah, lower powers, lower package size.
Right. And
That's probably the biggest new trend, I would guess.
what about levels of integration? How does that how does that affect you? Because I mean, you said that op amps and data converters are different groups, but so many times I've seen these AFE chips, the analog front end chips, and it's the same thing now. So how does that work?
Yeah, well, they definitely. I mean, we have groups within TI that will integrate pretty complicated solutions, and those are popular, but there's always some limit. They fit a certain set of categories, and not everything. So the discrete kind of amplifiers and data converters, they're not going away anytime soon. I mean, you have so much flexibility. Maybe at some time in the distant future. I mean, I remember 10 or so, maybe 20 years ago, I don't know. They were talking about building like programmable arrays of analog
Yeah.
electronics.
Analog arrays,
Yeah.
and that never happened.
Yeah,
did it?
no.
It just wasn't.
Right.
Why?
Because it just couldn't give you the kind of accuracy and capability
Yeah.
that you wanted, and
Right.
maybe the day will come for something like that. But right now, usually when you see these very high level integration, it's for a very specific problem, and it works well in that circumstance. And usually, it's hard for a discrete solution to compete with that integrated
Right.
solution.
Yep.
But then everything else is discrete.
Yeah, that's true, and it does seem well. I mean, so I used to work at Keithley, and it was like, yeah, any kind of integrated solution, we always said no thanks, because so much of it was that very specific, need this spec, need that spec. It was very, very hard requirement kind of things, and like you said, I mean the LMP lines that are meant for like sensors, which are great for someone like me now, just doing a quick off the shelf kind of thing. That's great, but wasn't good for doing a high end piece of test equipment.
Right.
Yeah. So speaking of some high end stuff, what about how are you teaching people about the really really advanced stuff? I mean, tell us about Precision Labs.
So this is definitely my favorite topic. we put a lot of time and effort into putting together a video series. But it's not just a collection of unrelated videos. It's really meant to be like a classroom. And the courses are sequenced in order of, increasing complexity, and there's an interdependency. So the second course requires the first one, and the third requires the first two. And it's just like a college program. In fact, at the end of each video, which normally ranges from 10 to 15 minutes, there's a quiz, which can be multiple choice, but is frequently much more complicated, like written out problems, and including simulation. So a person can go through a video, learn about how to drive a SAR data converter, for example, and then afterwards they can go through some exercises that where the problem is given to them, design a front end that does such and so. They do it, and then they can look at the solution and see, how close they were. Or maybe it's some more general things, multiple choice, and they can test their knowledge on that.
That's great.
Yeah, love it. And there's even, so we have two different branches right now, and we're planning on expanding it beyond that. But we have op-amp precision labs and SAR precision labs, or actually A to D converter precision labs. The op-amp precision labs has a evaluation module that is a PC board with a bunch of different op-amp circuits, inverting, non-inverting, cascaded, and so forth. And you can plug in different amplifiers. There's DIP adapter cards that you plug into the different op-amp circuits, and you can do experiments. So that's why it's called Precision Labs, because it has a hand-on component. Yeah. And so, for example, you can measure offset voltage, noise, slew rate, what else? Yeah, that's the only ones I could think of off the top of my head.
Power and temperature, noise, low distortion.
Exactly.
I'm looking at it, so don't worry about it. Yeah, it's not like I'm just coming up with this. Yeah. No, that's good too. And I really like ESD. That's a great one too, where you're actually measuring. Like, so it's what is it like testing the input ESD diodes, those kind of things, or is that what? ESD and electro
overstress, those don't have a lab component to it, because
you blow it up.
And people, yeah, exactly. It would be a very short lab.
Right.
You blow it up and you're done, right? But when we characterize devices for release, like in my old job, the test engineering job, we would plug a device into an ESD simulator, and it applies a pulse to the device and to different pin configurations, and you test it before and after, and you look for degradation in the performance of the device.
Oh, cool.
So that's the kind of thing that we talk about in Precision Labs. So how do we do our ESD testing? What are the different levels, and how do we protect from electrical overstress? What kind of external devices, like transient voltage suppressors or input resistors or what have you, can we use to protect circuits and make them more robust?
I'm looking at your YouTube channel now, and you've got over 3,000 videos. It's just incredible. You've got like 130 videos just on data converters.
Yeah.
I mean, and most of them are like, tutorial lessons and stuff like that. It's absolutely amazing. So do you have like a big media group that actually, a technical media group that actually produces all these, or do engineers, like the applications engineers, just go off and sort of produce their own thing every once in a while? Or
well, it's a little bit of both. In the case of Precision Labs, we internally produce them all, so those are the ones that I work directly on. And but there is a media group at TI, and they'll put together sometimes marketing videos. So some of those will be marketing related, and some of them will be technical. Mm-hmm. And sometimes it's engineers within the group that create them, and sometimes it's other groups that are more focused on training that put together that kind of material.
It's absolutely fantastic. Just the
Thanks.
amount of material out there is phenomenal.
I have to ask though, am I remembering right? Was it TI who did the Mayim Balonic or whatever her name was? Is that the one, Dave? Do you remember that? I think we did make fun of that on the show at one point. Was that TI?
No, that was Renesas.
You sure? Okay, well, whatever. Yeah, I remember.
Yeah, pretty sure it was.
That's when the marketing
Renesas,
people
yeah.
get involved. Like, oh, guys, no, let Ark make the
I
videos,
think it
please.
was anyway. I don't know. Yeah, it may have, but yeah, from for those who don't know, she's from The Big Bang
Yeah.
Theory.
Oh,
Sheldon's
right.
girlfriend. Right. Yeah, and then they hired her to do something. I don't know.
I thought.
No, we don't have that kind of budget.
Right. Okay.
Yeah. Oh man, that's funny. Yeah. So I also wanted to ask about. So I saw in the second lesson of this thing of the Op-Amp Precision Lab. I'm kind of lost now. It talks about the virtual bench. So is that integral to the National Instruments virtual bench? Is that using the actual big box for the test, or how does that work?
Yeah, it is. So we've got the hands-on experiments, and with this big PC board that lets you plug in the different devices, and you could connect it to really any lab equipment. It doesn't have to be the virtual bench, but the virtual bench is really convenient because it provides signal generator, 2 scope channels, power supplies. Just about everything you would need. It's DMM, actually fairly good precision DMM, and it's fairly small and compact, and it worked out really well for seminars. We actually took the Precision Lab, Op-Amp Precision Labs, all over the world. So we toured. It was kind of
cool.
we had a
Nice.
it was a little bit like being a rock star. We had a bus, and it was
And chip companies love those buses too. I don't know. Yeah. Admiral had one. Who else? Freescale had one at one point. Man.
Oh wow.
we
Yeah.
go from customer to customer and set up an all-day seminar, and it was pretty good.
Yeah. No, those are great too. I mean, like those. That's like. I mean, that's effectively like the electrical engineering version of continuing education for me. I mean, I know that there actually is that stuff for especially people like who have PEs and stuff, but that's the really valuable stuff to me was the vendor-based stuff. It's like, yeah, I might get a little bit of a sales pitch here and there, but really it was the applications engineers just showing me how to do cool things, and I'd happily hear about new parts because of that.
Yeah, and in a way, I'm glad you just mentioned the kind of product pitch type thing. One thing I was pretty happy about with Precision Labs is we're able to keep that out sort of for the most part. I mean, we basically it's strictly a teaching kind of program, and the way we sort of promote products in a secondary kind of way is all the products that we're using in the examples are TI products.
Of course,
so, there's a little bit of a, promotional aspect to it, and you get to see the good parameters and so forth. But we're not, like pitching products saying, oh, make sure you buy this one after you're, done with this.
Right. This sandwich brought to you by the OPA, whatever.
Yeah, exactly. So it worked out really good, and I'm glad that, my management let me do it that way.
Yeah, no, honestly, that's the best way to sell to engineers, in my opinion. I mean, I think, you just give good technical overview stuff, and I'm going to go and search your site for other stuff later, right? I mean, that's content marketing at its best, so.
Yeah.
Who gets to decide what banner specs go on a data sheet?
Ooh, good question,
and
Dave.
Which ones are buried down in the
the marketing
the
specs, huh?
asterisks, marketing.
That's the product definer, the guy that they actually go from customer to customer and visit with the customers and try and understand their applications and which specs are most important, and and they put the data sheet together and decide what it's going to look like, and then the apps engineers get to review the data sheet, and we might say, oh, change this or add that, and frequently we try and be consistent with the industry, so we just we work towards making a clear data sheet that people can compare well.
Yeah. Right, and honestly, that at the end of the day, that's what we want. We want apples to apples comparisons. That's always the hard part, especially when there's like specsmanship kind of intermingled. But yeah, it's appreciated when it actually is upfront.
Have you ever measured a device and got the characteristic curve and went, wow, that looks crap. We're not putting that in the data sheet. It's just we'll just put a rough parameter for that. We won't include the curve.
Well, I haven't personally, but
Right.
Yeah, David's kind of like asking him to be like, "Hey, can you identify yourself here, please?" Yeah.
It's completely. Yep. I was well aware of it.
Art, have you ever, or will you ever be a member of the product spec marketing team?
maybe it's better for me to be apps.
Yeah, right.
Right.
Right. That's funny.
Yep. Because sometimes there's just a characteristic curve that I bloody want and it's not in there, and it'll not, why didn't they include that? Their competitors got that one. Why don't they include it,
Sometimes it's just an oversight.
Right. Or someone couldn't be bothered. No one was tasked with doing it.
Yeah.
I guess. Right. Yep. Or it wasn't deemed important by
Right.
that marketing guru you mentioned.
If you look at data sheets, modern data sheets compared to some of the older ones, the number of data curves is exponentially increased. So in a way, they're going in the right direction. Although there's a balance, right? Because too much information can be not so good as well. It just can be overwhelming at times, I suppose. But I think we're moving in the right direction. We're trying.
Yep. It's easier because test systems are more automated now, and they can just spit these things out like nothing.
True, and then also, the types of curves or the types of specs more or less have been invented. At some point, somebody had to decide, let's create a curve that looks like this.
This,
and,
right? Yeah.
That's a good
and
point, yeah.
maybe a customer problem, became the mother of that curve, right? I mean, it's like, we need a curve that helps us understand this customer's problem a little better. And then you say to yourself, well, that really ought to go in the data sheet. And so I think that's how the data sheets have grown over time.
Oh, they've just collected more and more. It's like it's like baggage, right? It's technical baggage.
Right. Yeah.
Yeah, that's nice though.
What has ever happened to joke data sheets and having little Easter eggs in data sheets? Is that against company policy? Can you do a little doodle on the last page or something?
I don't think that would go on a data sheet anymore. Those days are gone. But I did do.
Why?
I don't know. Too serious, I guess.
No.
We did have a blog series, or we still have a blog series, and occasionally we'll have a joke blog. Like I did one for an April Fool's blog some years ago, where I said something like building an emergency transmitter. If you're shipwrecked on an island, and it was a whole Gilligan's Island spoof kind of thing, and it was fun. It was enjoyable putting it together, and people got a kick out of it. And in fact, we had all these technical blogs, and that particular one was rated, way higher than all the technical ones. And so,
hurt some feelings, huh?
The marketing people all decided, well, we have to do all spoof blogs now.
That is not the right answer, right?
It's getting all the social media engagement. Yeah.
Oh, man.
So.
It's meeting all those KPIs we need.
Yeah, that's not good. Yeah.
Oh man.
Well, so you're Art, you're in charge of SAR products now. I mean, where are you seeing that going? I mean, what is obviously? I'm sure ADCs are getting faster and faster and less noisy, but what other trends are you seeing?
Well, I would say that the biggest trend for SAR is that the resolution is getting higher and higher, which I wouldn't have really expected it, earlier in my career. You think of a Delta Sigma converter as a 24-bit converter.
Yeah.
That's what I normally think of.
Yeah,
integrate for 3 days, and you got a great reading.
Yeah. Right.
But now SAR converters are 20 bits, 18, 20 bits. It's common for that. And then normally, a few years back, SAR converters were usually a more basic SAR, where it was a switch capacitor input, a reference input, and digital output. But now you're seeing more and more levels of integration within the SAR converter, similar to what you've seen in PGA Delta Sigma converters, that is, for a number of years. And Delta Sigma converters are normally more integrated. You'll have a programmable gain amplifier, an internal reference, maybe some current sources for exciting thermocouple or RTD or something like that, bridge excitation. And now you're starting to see that in SARs, where you see internal references, reference buffers, PGAs. And so that's another trend. And then I think the last trend is that the size and power of the SAR is getting lower and lower. And so we have one type of SAR, we call them nano SARs, and they're it's so small that if you had a pile of them on a piece of paper and you breathed, you'd probably inhale a bunch of them.
Right.
They'd be in your lungs and so forth.
Right.
So they're very, very low power and super tiny.
Give us for those playing along at home, give us the key differences between a Delta Sigma and a SAR, which is successive approximation converter.
So a SAR takes a snapshot of a voltage or a signal. Basically, it does that by having a switch on the front end, and the switch opens, and whatever signal is it connected to the SAR input gets stored on a sample and hold capacitor. And there's some resistance associated with that sample and hold capacitor. So you have to make sure that switch is closed long enough for that internal sample and hold capacitor to charge up. And that's one of the big challenges with the SAR, is just making sure that you can drive that input or allow that input to settle, in time. But once it's settled, that switch opens and then the conversion occurs. And you can kind of think of the conversion like a weigh scale. You have your voltage applied to the input of a comparator that's stored on the sample and hold capacitor. And then you have a DAC and the other input of the capacitor, and it's servoing through different voltages, trying to match the voltage on the sample and hold capacitor. And once it matches as close as it can, all those different comparisons are stored in a register, and that's the conversion result.
Yeah.
So I guess the important thing to take away from it isn't so much how it's converting, but that it will take a snapshot. So as soon as that switch on the front end opens, whatever voltage we were at is the voltage that the conversion will be equivalent to. Whereas a Delta Sigma converter, it's taking thousands of samples on a single bit type converter, and it's using kind of a control system to average those samples. So over a long period of time, it might be 1/60th of a second. We'll be averaging the voltage, and then we'll get a very, very accurate, very low noise result. But at least for one kind of Delta Sigma converter, it's normally a much slower,
Very slow, yeah.
And it's frequently in, like 1/60th of a second. So it could integrate out the power line cycle, or 1/50th of a second, depending on, Europe or US.
Yay, Australia.
Yeah.
50 hertz all the way.
So that's one type of Delta Sigma. And there's a more wideband Delta Sigma type converter, which again averages, but you can get a faster throughput, and that might be used for seismic measurements or ECG or something like that.
That's the field I come from. Yep.
Yeah, and they have a different kind of digital filter in that than the slower ones.
So the DAC in your SARs, how do you normally do the DACs in those?
It's a switched capacitor DAC. It's CDAC capacitively. Yeah.
So what is driving these higher bit rates then? Is it just that the DACs are, I guess the clock's getting faster, but that's not necessarily it. Is it just that it's just doing more registers? It's able to switch faster? Or what's driving that?
Well, you are You do have to clock it faster. Normally, the conversion is internally clocked on these precision SARs, and once its conversion is complete, you're going to have to read the the data back out of it. And it's actually a challenge, right? Because you have 20, normally most SAR converters will have a serial interface. And if it's 20 bits, and if we're going at, let's say, 4 megasamples per second, you can imagine that we've got to clock pretty fast.
Right.
And so we've actually developed kind of a new SPI, we call it multi-SPI. And it does a whole wide range of different capabilities. This is an extended version of SPI interface, but one feature that it has that allows it to sort of reduce that throughput rate or the digital communication rate is that you can have multiple data lines. So it's kind of a hybrid of serial and parallel.
Yeah.
Nice.
And so you can have you can have a standard SPI, so one data line, or you can have 2 or 4. And you can even collect data on the rising edge of the clock and the falling edge of the clock. And so by doing that, you can slow down your clock speed, and it's a little easier to communicate.
How do you internally run these sample clocks? Is it a free running oscillator? How do you do that? Because it's not clocked externally, right?
Right. It depends on the converter. The older style and maybe the lower resolution converters, they will be clocked externally, or often are. But internally, there's going to be an oscillator. For the precision SAR, there's going to be some internal oscillator.
And that's just an an internal RC thing, or is it process controlled frequency, or how does that?
Well,
I assume there'd be a large tolerance on that, temperature dependent.
It's got to be. I'm not the designer, and I don't know exactly how they do it, but jitter and drift and all these kinds of things can impact performance. So whatever they're doing, they're doing it well because
they're doing it well.
Yeah. So it's a good question for me to ask those guys.
Okay. Yeah. Because it's not like they have an internal crystal element. I mean, you've got to do it in silicon somehow.
Yeah, I don't know honestly.
So, yeah.
So what about the
fascinating
is
topic.
Is there any requirement for using like SerDes these days, like the really higher speed transceivers? Is there requirements on the digital side to do that, or can it just be standard SPI ports, but like daisy chaining them, or not even, it's multi-ganging them, I suppose, not daisy chaining?
You can. There are some daisy chained capabilities, and so.
But is there a requirement to use like the high speed transceivers that are getting put on a lot of FPGAs and stuff like that, or is it?
I don't think they're getting that high.
Right.
They're not that high a frequency to warrant those.
I
I mean, those are like gigasamples sometimes, but starting to push that. I mean, it's hundreds of megasamples, right? So.
Well, we're not going into the hundreds of megasamples. The SAR converters that at least are from my precision group are usually about 5 megasamples is the max. So there's another high speed group, and would like to learn more about that, but right now I'm focusing more on the precision.
Yeah,
SAR.
I guess the precision starts to fall off as you go faster and faster too, huh? Yeah.
Yes.
Okay.
Oh yeah.
I guess my math was wrong, huh? If 5 megasamples, my math is way wrong then. Okay.
Yeah, you're off by
Yeah,
several orders there,
okay.
Chris.
I'm doing it in my head. It's fine.
Yeah.
I need some kind of pocket guide or a analog calculator. Or I need Maya Bialik to tell me about zombies, because I did look it up, and it was her, and it was for Texas Instruments. So,
Guilty as
Yeah.
charged. TI.
I will put that in the show notes because
We will.
Yeah,
we're gonna have to watch that. Is the video?
it was a
is
little cringy, but it was well-meaning. It was well-meaning. I will say that. And
Right.
our stance is that it's better to have art doing videos. That's what. So, Art, what else should we know here? I mean, we're kind of wrapping up. I mean, what else do you want people to know about your group, or about the learning opportunities, or anything like that?
Well, I guess a few things I could mention. One of my areas of expertise that I spent a lot of time on is noise analysis, and so I wrote a book, Operational Amplifier Noise, and so I've spent quite a bit of time. People come to me for noise type questions, and so that's just a good resource. So on Precision Labs, Op-Amp Precision Labs, there's kind of a summarized version of what the book is about in video form. But Yeah, that was something I spent a lot of time on. My colleague Tim Green, we worked together in a lot of different projects. He's working on similar material for op amp stability, which is another kind of challenging problem.
Yes, it is.
So he has an article series, and eventually we'll get a book out on that subject.
So you both write for the E2E blogs and stuff like that too?
We have. I've tend to past, let's say, 3 or 4 years, I've spent more time just putting together Precision Labs than putting blogs out. Okay. And prior to that, I wrote a lot of articles. There was a article place called EN Genius, and they shut it down, but it was a really good website, and we could write extremely long, detailed articles, which was really nice to have that flexibility. And a set of articles from that magazine became my book, so that's how it worked out.
Okay, that's great. There's like long form engineering stuff. Yeah, that is kind of doesn't fit super great with the with the internet these days. But man, when you find that article you need, it really does it.
The 5-minute attention span limit.
Yeah.
Yeah, we need more Mayim Balak.
Yeah. Art, where can people find you online? I mean, are you you're not a Twitterer or anything like that?
Well, I'm on LinkedIn, so you could search me up on LinkedIn, and I guess there's also an E2E network, which is TI's way for answering questions. So if a person posts a question, we'll go up there, and I answer sometimes on the E2E forum, or you could befriend me. It's kind of similar to, I guess, Facebook or something like that, where you can have friends, and so you could send me messages that way. So occasionally somebody will ask me some noise question, or I'll work on the SAR converter type things.
Awesome.
Are you guys hiring at the moment?
Yeah, we're always hiring, and especially I would say new college grads. There's a huge amount of college recruits, and so and a very good program too. There's most engineers will go through a rotational program at TI, and it depends on the different area that you're in. But for applications, it's a 1-year rotational program, and you'll go to 2 different groups, and you'll have training in between, at the beginning, in between, at the end. There's a network of young people that work with each other to, go on hikes and stuff like that, and to help each other out. And so it's a very good environment for, I would say, new college grads. Much better, as I mentioned earlier. It's a much better way to go than what I, sink or swim when I was an engineer.
Right. Yep.
A lot of help and support for these guys.
Right, and we should mention too, thanks to Victor, who introduced you and I through. Victor was one of those. He went through the rotational stuff, and he actually introduced you and I. So that was great.
Oh, thanks, Tim.
There you go.
Yeah.
It's not as exciting as a dodgy startup, though, is it?
Yeah, there's definitely.
Go work with a nice, stable company like TI doing cool analog stuff. How do you compete for these graduates these days who are just all schooled to go do startups? Is that have you seen like the interest drop in recent times for like, I don't like to use the word boring, but boring in quote marks stable jobs, because a lot of focus on university courses seems to be entrepreneurial these days.
I would say no. I haven't. I've seen it, if anything, kind of increase. I mean, we're hiring massive amounts of people, but I would say that many, if not most, college students focus on digital, so very often they'll come to me during the on-campus interview type career fair, and I'll say, what do you like, analog or digital? And they'll have all digital on their resume, and they'll be, I love analog. So they're both great.
Wait. What does your card say, Art? I love analog.
So there's more emphasis on digital for sure, and so it's more difficult to find really good analog, especially people who have a passion for analog. You'll have people. It's almost easier to find undergraduate students than graduate, because you definitely get your first couple labs, you're doing amplifiers and transistors, and you get plenty of analog. And then frequently people will go into grad school and they do VHDL
and Verilog and
Ew,
yeah, right.
how could they?
So, yeah, I would say that's more the problem than lack of interest.
Okay.
Cool.
Interesting.
Well, I'm sure there's some people in our listening audience who are young, enthusiastic analog future gurus. So hopefully they'll jump over your way.
Send them our way. Yeah.
No shortage of jobs in Tucson, Arizona.
That's right.
Yes.
Awesome. Well, Art, thanks so much. I mean, definitely some great resources you
great.
shared here, and I'm looking forward to checking these out more.
It's been a pleasure. Thanks.
Thanks, mate. Catch you next time.